Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry related to shortest distance between two non-coplanar lines, right? Viewers, we have already discussed the concept of shortest distance between two non-coplanar lines in our earlier videos, and in this class we are going to solve one important problem related to shortest distance between two non-coplanar lines, right? So let us start. So here we have to find the shortest distance between these two lines, right? So let us call this line as L1 and this line as L2, right? So these two lines are given in this form, that is x minus x1 over a1, y minus y1 over b1, and z minus z1 over c1, right? And similarly this line is of the form x minus x2 over a2, y minus y2 over b2, and z minus z1 z2 over c2, right? So x1, y1, z1 is the point through which this line passes, and a1, b1, c1 are the direction ratios of this line L1, right? And similarly x2, y2, z2 are the point through which this line passes, and a2, b2, c2 are the direction ratios of this line L2, right? So now if we compare these two equations, we get x1, y1, z1 as 3. Here we have 3, then we have minus 15, and then we have 9, right? And the direction ratios are a1, b1, and c1. These are given as 2, minus 7, and 5, right? And similarly here we have x2, y2, z2 as we have here minus 1, then we have 1 and 9, and a2, b2, c2 are the direction ratios are given by 2, 1, and minus 3, right? Now here if we closely observe the equations of these two lines L1 and L2, we conclude that these two lines are non-coplanar, right? And we have to find the shortest distance between these two lines, right? It means the first line it lies on some plane P1, and the second line it lies on some other plane P2, right? And this is the line L1 which lies on this plane P1, and this is the line L2 which lies on this plane P2, right? And we have to find the shortest distance between these two lines, and here if we take this point as M and this point as N, then MN is perpendicular to both the lines, right? And MN is the shortest distance, right? So let us denote the shortest distance by the letter D, right? So now we know that the formula for calculating the shortest distance is given as a2 minus a1. So here we have the difference of the vectors a2 and a1. Then we'll take the dot product with b1 cross b2, and then we'll divide it by the magnitude of b1 cross b2, right? And then we'll take the absolute value of this quantity, right? So now we have to apply this formula to find out the shortest distance between these two lines L1 and L2. Now if we see the standard notation, then this vector a1 is given by these coordinates, right? So this is vector a1, and the this point, that is x2 y2 z2, is given by the vector a2, and here these direction ratios a1 b1 c1 are given by the vector b1, and these direction ratios a2 b2 c2 are given by the vector b2, right? So here these are the x, y and z components, and similarly here we have x, y and z components, right? So vector a1, it can be written as 3i cap minus 15j cap plus 9k cap, and vector a2 can be written as minus I cap plus j cap plus 9k cap, and vector b1 is given by 2i cap minus 7j cap plus 5k cap, and vector b2 is given by 2i cap, then we have j cap, and then we have minus 3k cap, right? So now we have expressed all these numbers in the form of vectors, right? So vector a1 represents the point through which this line L1 passes. Vector a2 represents the point through which this line L2 passes, and vector b1 gives the direction ratios of the line L1, and vector b2 gives the direction ratios of the line L2, right? So now we have vector a1, vector a2, vector b1 and vector b2, and now we can calculate these three quantities. So now let us first calculate vector a2 minus vector a1, right? So a2 minus a1 is given by minus 1 minus 3 I cap, then we have 1, here we have 1, and then minus 15, so this becomes plus 15, and this is j cap, and then we have 9 minus 9 k cap, right? So vector a2 minus vector a1 is given by minus 4 I cap, and here we have 16 j cap, and this 9 minus 9 is 0, right? And b1 cross b2, the vector product of vector b1 and vector b2 is given by this determinant. So the vector product of vector b1 and b2 is I cap, j cap and k cap, and then the second row is occupied by these numbers, that is 2 minus 7 and 5, and the third row of this determinant is occupied by these numbers, that is 2, 1 and minus 3, right? So now this vector product can be calculated by solving this determinant. So now we can write here we have I cap, and then we have minus 3 times minus 7, that is 21, minus 5, then we have minus j cap, and we have minus 6 minus 10, and then we have plus k cap, and here we have 2 plus 14, right? So now we have here 16 I cap, then we have plus 16 j cap, and then we have 16 k cap, right? So this is the vector b1 cross b2, right? Okay, so now we have obtained a2 minus a1 and b1 cross b2. So now we have to find the dot product of these two vectors. So a2 minus a1 dot B1 cross B2 can be calculated as here we have minus 4i cap plus 16j cap, and then the dot product with this vector, so we have 16i cap plus 16j cap plus 16k cap, right? So we know that how to find the dot product of two vectors. So we'll take the II components. So we have minus 4 and 16, and then we have the j component. Here we have 16, here also we have 16, and here we do not have any k component, so we can write 0, and here we have 16, right? So this is minus 64, and this is 16 times 16 is 256, and this is 256 minus 64 is 192, right? And 0 times 16 is 0, right? Now we have to calculate the magnitude of B1 cross B2. So the magnitude of B1 cross B2 is given by square root of, here we have 16 square, then we have 16 square, and then we have 16 square, right? So we have here 16 square. So now we can write it as 16 square can be taken as common, so we have 1 plus 1 plus 1, and this is we can take 16 outside the square root sign, so we have 16 root 3, right? So the magnitude of vector B1 cross vector B2 is given by 16 root 3. So now the shortest distance between these two lines is given by this formula. So we'll substitute the values. So now we have here the dot product of A2 minus A1 with B1 cross B2 is 192, and the magnitude of B1 cross B2 is 16 root 3, right? And we have here if we cancel this 192 with 16, so we have 16 ones are 16, and then we have here 2, so this is 12 over square root of 3, which can also be written as 12 over square root of 3 times root 3 over root 3, and this is 12 root 3 over 3, and this is 3 fours are, so we have 4 root 3, right? So viewers, the shortest distance between these two non-coplanar lines is given by 4 times square root of 3 units, right? So this is how we find the shortest distance between two non-coplanar lines with the help of this result.